Hello and welcome. Today, let's explore Apica Ascent telemetry pipeline capabilities for Splunk. In this demo, we will demonstrate how Apica's telemetry pipeline can intelligently reduce data volume and noise before it reaches Splunk, helping to optimize performance, cut costs, and ensure only the most valuable insights are retained. To start, let's review a typical Splunk enterprise architecture. In most setups, multiple universal forwarders collect telemetry from various sources and send it to a centralized heavy forwarder. The heavy forwarder then sends the data to Splunk. In some cases, universal forwarders may send data directly to Splunk. At Apica, we simplify and optimize this process. We position ourselves between the Splunk agents and the Splunk indexer, receiving data from all available sources, including heavy forwarders and universal forwarders. From there, we process the data through our telemetry pipeline before forwarding it to Splunk. Apica Ascent's telemetry pipeline offers powerful rules capabilities to enrich, filter, or mask data before it reaches downstream systems, such as Splunk. Additionally, you can retain full data fidelity by integrating Apica Lake into your stack. This cost-efficient approach leverages object storage, enabling you to pre-process data and forward only filtered relevant events to Splunk while storing full fidelity data within Apica Lake so that you can even replay past data when needed. Now, let's get started with setting up the entire workflow. We have a Splunk Cloud instance that we'll use to set up the necessary components for sending processed data from Apica's telemetry pipeline to Splunk. The first step is to create a new index. We'll name it Apica Demo. Set the data type to events. Configure the data size as 0 for unlimited data. And set the retention to 7 days. Click Save, and the new index is ready. Next, we'll create a data input using the HTTP Event Collector, HEC. We'll name it Apica HEC Demo. Set the source type to JSON, and link it to the Apica Demo index. Review the settings and submit. We will copy this token value, as we'll need it later. Now, let's create a simple dashboard to visualize the data that will be ingested into Splunk from Apica Ascent. We'll name it Apica Demo, use a classic dashboard layout, and add a few panels. First, create a single value panel to display events per second, that is, EPS from the Apica Demo index, and add it to the dashboard. Next, add a line chart panel to show EPS trends over time, and add it as well. Save the dashboard. At this point, the dashboard is ready, though no data is yet being ingested, so the graphs will appear blank. With this, we've completed all the necessary setup steps within Splunk. Next, let's navigate to the Apica Ascent platform to set up a source extension and a forwarder. First, go to Integrations, Source Extensions, and create a new source extension for S2S ingest. Name it Splunk Demo. Leave resources as default for this demo. Set the source type to JSON, and leave the protocol version blank. This allows the forwarder and receiver to negotiate the latest common available protocol. Click Done. The S2S ingest plugin is now created. Within a few minutes, a new load balancer IP will appear on the screen. We'll come back to this shortly, but for now, let's create the Splunk forwarder. Switch to the Forwarders tab. Click Add Forwarder, and select Splunk HTTP Event Collector. Enter the HEC token generated from Splunk and specify the host where the HEC token belongs. Keep the type as JSON. Name the forwarder Splunk HEC, and click Create. The forwarder is now ready to send data to Splunk. Now, return to the previously created source extension. The load balancer IP should be populated. This is the IP we'll configure in the Splunk agent to forward data to Apica Ascent, and it acts as the indexer. Let's configure the Splunk agents, the UF, and the HF. On the universal forwarder, you'll notice no data is being forwarded yet. Run the add forward server command to point it to the heavy forwarder. Verify the forwarding status using the list forward server command. All good now. Next, configure the heavy forwarder to forward data to Apica Ascent. Use the add forward server command with the load balancer IP from the S2S source extension, and confirm the forwarding is active with list forward server command. With this, the agent configuration is complete, and data is now being ingested into Apica Ascent from the Splunk agents. Finally, let's verify the data flow. Navigate to the Explore page and select the source extension name Splunk Demo. You'll see that data is being ingested into our platform via the heavy forwarder, giving you full visibility of the incoming telemetry. As the next step, we'll focus on our final goal, creating a pipeline to reduce data volume by filtering unnecessary fields and events. To create the pipeline, navigate to Explore and select Pipeline from the list. This will take you to the pipeline dashboard, which shows all active pipelines within the stack. Switch to the Pipelines tab. Select Actions. And click Create Pipeline. We'll name it Splunk Demo and click Create. Then, click the ellipsis menu and select Configure Pipeline. A pipeline is a sequence of stages through which data flows systematically, applying different sets of rules to process it efficiently. To make rule creation easier while previewing data, select Data Flow in the right pane. Let's add a few filter rules. First, we'll suppress duplicate events. Name the rule. Navigate to the Suppress Events tab. Enable it. And set the suppression period to 120 seconds. With an allowed count of 1. Enable dropping duplicate events for this period. This completes our first rule, which will drop any duplicate events within a 120-second duration and keep only one event. Next, we'll add another filter rule to drop entire events based on specific criteria. For example, if the source type is equal to KV-store, the pipeline will drop all events from that source type. Save the pipeline. From this screen, you can also preview the pipeline to see its impact. Run the preview, and you'll notice certain events are being dropped, confirming the rules will take effect once applied. You can also drop unnecessary labels from events to reduce data volume without discarding entire events. Let's add one more filter rule to remove selected labels from the structured data. After making these changes, save the pipeline. At this point, the pipeline is created along with its set of rules, but it's not yet assigned to any data flows, so it has no effect yet. To apply it, click the ellipsis menu and select Apply Pipeline. Choose the appropriate namespace and application, then click Apply. Now the pipeline is active, with one data flow using it. This screen also displays important statistics, including events ingested, events processed, and the volume of data saved. The pipeline is now active on the data flow. Let's quickly preview its impact. After a minute or so, you will start noticing some savings reflected in the platform. Next, let's map the Splunk forwarder to send the filtered data to Splunk. Select the data flow. Open the ellipsis menu. And choose Map Forwarder. Select Splunk HEC from the list. The destination is now set to Splunk, and the processed data should start arriving there. Now let's switch to Splunk. Go to Search and Reporting. Select the index we're sending data to, and run a search. You'll see that data is being received from Apica Ascent. Let's also check the dashboard we created earlier. As data starts flowing in, we can see EPS trending upwards, exactly as expected. Let the setup run for a while and observe the trend. After about 30 minutes, the EPS stabilizes around 15 to 20. Showing a steady and continuous data flow with no major spikes, everything looks fine. Now, let's review the stats in Apica Ascent. Select the data flow and switch to the Pipeline tab. You'll notice that while around 33,000 events came in, only 437 events were forwarded to Splunk. That's a significant amount of event reduction, demonstrating the effectiveness of the pipeline. Finally, on the main pipeline screen, you can view metrics for all active pipelines in the stack. You can also drill down into individual pipelines to see savings per rule, giving full visibility into how each rule transformation impacts the data. We'll leave the setup running now and return after 12 hours to review the results. Next, let's check Splunk's EPS trend. The trend looks stable and consistent. Now, let's turn the pipeline off and observe the impact. As expected, we see a quick jump in EPS, confirming that the pipeline is effectively controlling data volume. After 15 minutes with the pipeline off, the EPS remains higher. Turning the pipeline back on brings the EPS down again, demonstrating its ability to efficiently manage and reduce data flow as intended. And that concludes our demo, showcasing how Apica Ascent's telemetry pipeline can efficiently process, filter, and forward data to Splunk, while significantly reducing data volume and maintaining full visibility. Thank you.